All right. That was Elvis Presley. If you don't know who Elvis Presley is, he was before your time, but famous rock singer from a ways back, and he's pretty popular for his songs, but also for his dancing. He was the first one to go up and do some crazy dancing on stage or on TV. So that's one of the things he's popular for. But his birthday was on January 8th, so happy birthday to Elvis. We're going to do section 6.5 today. Um, it's all about rhombuses, rectangles, and squares again, but we're going to prove whether they're rhombuses, rectangles, or squares. So there's your goal there. I can determine whether a parallelogram is a rhombus or a rectangle, or a square will be on there as well, but a square is a, um, both of those could be a square, or a square could be either one of those. Um, so, how can you prove a parallelogram is a rhombus, square, or rectangle? Well, first let's define what they are, because definitions are the first ways. A rhombus, we've said this before, a rhombus is a parallelogram with four congruent sides. So you can prove it's a rhombus if you can prove that it's a parallelogram and it has four congruent sides. You can prove it's a rectangle if it's a parallelogram with four right angles. Doesn't matter what the sides are, as long as you have a parallelogram with four right angles. And more specifically, a square, you have to prove both, well, a parallelogram and that it has four congruent sides and four right angles. So those are those definitions, just to review. But you can also prove it with some theorems. We have some theorems here for you that have to do with diagonals. The diagonals of parallelograms, and we've talked about that before, what diagonals are. So this first one, 616, so the 16th theorem of this chapter, we've got a lot of them. If the diagonals of a parallelogram are perpendicular, so if you can prove that those those diagonals are perpendicular, then the parallelogram is a rhombus. So if the diagonals are perpendicular, then it's a rhombus. So we have our picture here. If parallelogram ABCD has diagonals AC and BD perpendicular, then it's a rhombus. So then if we know it's a rhombus, we know all four sides are congruent as well. Theorem 617 says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Interesting. So if you just have at least one of the parallelogram diagonal bisects a pair of opposite angles, so it has to bisect both opposite angles, then it's a rhombus. So there's another way to prove it's a rhombus. So we have parallelogram ABCD here. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, which means that that diagonal bisected those angles, meaning it's also a rhombus. Could be a square, but we can't prove that much. We know that it's just a at least it's just a rhombus with this theorem. And the last theorem that we have for today is theorem 618. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay? You can probably guess that for a square, those diagonals they bisect the angles and they're congruent. And they're perpendicular. Alright, but rectangle, so if the diagonals are congruent, then it is a rectangle. So there's our three theorems. Let's use those theorems now. Got a couple examples here. The first set, I think these are all in your notes. It says, can you conclude that the parallelogram is a rhombus, rectangle, or square? Explain. So maybe neither, but it's a rhombus, rectangle, or square. So we don't have anything with the sides or the angles. If we look at number one, though, we have that the angles bisect each other, or the diagonals bisect each other because it's cutting these in half. So we know it's a parallelogram, first of all, but we're already given that. We have this nice little right angle symbol, which means that we can prove that it's a rhombus because the diagonals are perpendicular. Now, I don't think we can say anything else about it because we don't know if the diagonals are congruent. We don't know if the diagonals bisect the angles. We're just going to leave it as being a rhombus right now. Now, number two, we're given that it's a parallelogram, that these things bisect each other because this is congruent to this is congruent to this. I don't know that we have anything else here. We don't have that they're perpendicular, the diagonals are perpendicular. We don't know necessarily that the diagonals are congruent. Um, unless we can prove that they're congruent. So let's look at this. Let's see if we have, this would be congruent to this. So now we have that these two triangles, top and bottom, are congruent by side, angle, side. Side, angle, side. So that means that, well, that means that this is congruent to this. So we still don't have enough there. We know that they're congruent, but we don't know that the diagonals are congruent just yet. So I mean, we can tell that it's going to be a rectangle, but we can't prove anything here. There's not enough info. And then number 3, well, we have that the diagonals are perpendicular. Thanks to that. So this is also a rhombus. All right, let's go on. We have a few questions here. I think these are in your notes, hopefully. Parallelogram. It has two pairs of adjacent sides that are congruent. So if a parallelogram has two pairs of adjacent sides that are congruent, so if you draw a parallelogram, however it is, we know that this is congruent to this. Two pairs of adjacent sides are congruent. This is congruent to this. But it is a parallelogram, and the sides that are next to each other are congruent. The opposite sides have to be congruent. We know that it's at least a rhombus because all sides are congruent then. Could be a square. Number 5, a parallelogram's diagonals form 8 congruent angles at the vertices. So it's a rectangle for sure. But if this is congruent to this, this is congruent to this. If they're all congruent, we know it's a rectangle, but we also know that it is a square because all the angles are congruent. Yeah, let's look back at our theorems. Where do we know that's a rhombus? We know it's a rhombus, but we know that it's, if they're all the same, then that's a square. All right? Ooh, I almost mixed up those theorems there. Whoops. All right. Now, these examples are a little bit different. You're actually given what they are. We want to figure out to actually, for that to be what it is, what would x have to be equal to? So if you look at this, interesting. The first one, we have that this smaller angle here is 2x minus 1. We have that the obtuse angle here is 4x plus 28. Based on if it's a rhombus, these have to be congruent. They'd have to be, this would have to be an isosceles triangle here. So we know that two of those, so 2 times 2x plus 1, sorry, minus 1, plus the 4x plus 28 would have to equal 180 for that triangle. So we look at this, we have 4x with our 8x, or plus our other 4x would be 8x. And this would be minus 2, and then plus 28 would be plus 26 equals 180. 2 steps then to solve, minus 26 on both sides. And we have 8x equals 154. And divide 154 by 8. Get your handy dandy calculator. And 154 divided by 8. I did that right. 154 divided by 8. It's like 19.25. Now, that doesn't seem right. And I'd have to check my notes. But for right now, if I did make an error, please report that next time you see me. All right. Let's go on to number 7. Number 7. We are given that these two things, we know that the diagonal, rectangles, we know that the diagonals have to be congruent, don't we? Where is that? Right here, Theorem 618. For if the diagonals are congruent, then it's a rectangle. So diagonals have to be congruent, and they have to bisect each other, so these would have to be congruent. So 9x minus 9 would have to be equal to 7x plus 1. Wow, crazy stuff going on here. Okay, and then we can solve for x. We'll get the x's on the same side first. We have 2x minus 9, and actually we can add 9 to both sides right away then. Equals 10, and x is going to be equal to 5 when you divide both sides by 2. Alright, we're going to skip the other two and go on to this section right here. It says determine whether the parallelogram is a rhombus, a rectangle, or a square, given the parameters there. We want the most precise one. So a parallelogram has number 9, a parallelogram has perpendicular diagonals. So it's going to be a rhombus, we know that. Right? Perpendicular, yeah, there you go, it's a rhombus. And angle measures of 45, 135, 45, 135. So that is going to be a rhombus. That is not a square. Parallelogram has perpendicular and congruent diagonals. So the perpendicular diagonals mean that it's a parallel or a rhombus. Congruent diagonals would mean that it's also a rectangle. So what type of a parallelogram is a rectangle and a rhombus? Well, that would of course be a square. All right. Yep. A rectangle has perpendicular diagonals, so there again it's a rhombus and angle measures that are all 90 degrees. Ah, so that is a rhombus it's also a rectangle, which means that it would be a square. A parallelogram has congruent diagonals, so that's all we know is it's going to be a rectangle based off of that theorem. And that is what we're going to end with. So what I'd like you to do is answer the closing questions on your own, and we'll see you next time.